Alright guys, we're going to be doing the domain of rational functions today, and I want to go through the three examples that you find on your worksheet, and hopefully we can get you guys through these. So example 1 looks like this. We have f of x equals 4 divided by x minus 2. So the domain is basically all of the x values included for this function. So what we're trying to find is essentially what x's can I plug in and what x's can I not plug in. This entire worksheet is going to be dealing with dividing by numbers. So it'll be 4 divided by x minus 2 or x divided by x plus 3. So that's kind of where we're headed. We're trying to figure out basically what x's can I plug in, what x's can I not plug in. So the issue in all of these is going to be dividing by 0. So obviously dividing by 0 is not a good thing. So what's going on there is we're trying to find out what values of x make us divide by 0 in these functions. So anywhere the denominator is equal to 0 is going to be an issue for us. So the denominator in in example 1 is x minus 2. So if I can find out where x minus 2 equals 0, then this will be where my only issue is for this problem. So x minus 2 is equal to 0 when x is equal to 2. So in other words, for this problem, or for this function, x cannot equal 2. If it equals 2, then it's undefined. So the way our answer will have to look here, you could look at it on a number line like this. Basically, we could include every value, every real number except for 2. Right up until 2 and right after 2 would be fine, but 2 itself does not work. So I'm going to want you guys to give the answer in a interval notation. So all the way to the left, we have negative infinity. We go to 2, and then we go up to positive infinity. So our answer would look like this. An open interval on negative infinity over to 2. Another open interval, which is just a parentheses. And then another interval here, starting at 2, going up to positive infinity. So this would be our final answer. So basically, it includes all numbers except for 2 itself. Example 2 is 2x divided by x squared minus 9. So now we get into one that has a little bit more of an intricate denominator. So we're going to be trying to find out where is x squared minus 9 equal to 0. You could factor this using the difference of squares, but we could also just add 9 to both sides, so we have x squared equals 9. Then the square root of both sides gets the x by itself, so x would equal plus or minus 3. Or in other words, x cannot equal plus or minus 3. Now if you notice, the top here of example 2 has a 2x. Now what's on top, we're not going to worry about that too much today. We're going to be really focusing on the denominator. We'll get into some more of what happens of the top versus bottom later on. But for now, we're just worrying about what's happening on the bottom. So, starting out with the number line, everything works except for negative 3 and positive 3. So we'll have these open circles. We did some of these intervals back when we talked about inequalities. So our answer will look kind of like this. We'll have an interval from negative infinity up to 3, the negative 3 not including it, from negative 3 to positive 3, not including the endpoints, and then from 3 to infinity. And all of these are parentheses for this because we cannot actually assume those values. Alright. Now example 3, our last one for this little video, is f of x equals x over x times x plus 3. So now, again, we're trying to find out where the bottom is equal to 0 because that's going to be where our issues arise. So x times x minus or x plus 3 equals 0. So this is basically in a factored form if you want to look at it that way. So if either of these individual factors are equal to 0, then we'll have a solution to this x times x plus 3 equals 0. So in other words, x equals 0 is the solution to this left-hand side, and the right-hand side of my problem would be solved by setting x plus 3 equal to 0, where the solution is x equals negative 3. So, x cannot be 0, x could not be negative 3. So next step is to jump into our number line, where we can have any value except for negative 3 and 0. And our intervals would look like this, from negative infinity to negative 3, from negative 3 to 0, and then 0 to infinity. And that would be your final answer for example 3.